Hey guys, and welcome back to day 4 of online learning. This is your assignment for Wednesday and Thursday. A couple things real quick. Make sure you're reading the announcements, checking your emails. If you have not yet taken the WAVES test, then I have already emailed you about taking it. Please get that into me by Friday, por favor. And let's go ahead and take a look at our assignments. So, a quick reminder of things that might be changing for us. So you're only going to have 2 assignments per week. Those are your Monday, Tuesday, and then your Wednesday, Thursday assignments. Fridays are reserved for sort of checking in with your teachers. I'm going to be hosting Google Meet sessions on Friday. During that time, please feel free to just drop in just to say hi, to get some extra help. I can schedule one-on-one like tutoring times through Google Meet. If you haven't used this platform before, then it can be a sort of like a video call, or can be sort of a phone call, could be sort of an online chat. There's also a way for you to sort of present your screen to me, or I can present my screen to you, and we can sort of work through the problem together. Okay, so just a thought. Let's see. Quick note about yesterday's assignment. So the exit ticket, that is your attendance. The assignment is your grade. We are still going forward taking 1 grade per week. I will let you know if anything about that grade changes in the future, okay? Let's see. Oh, on your exit tickets, I really enjoyed reading what you guys did over spring break. So I'm loving how much just outdoor time everyone's getting. A lot of people went biking or fishing or hiking with their family. I'm really hoping that like after all this is over, people sort of realize just how important, nature is, and maybe get on protecting it. That's awesome. Other than that, a shocking number of you we're playing Animal Crossing. I guess that's the current obsession. Understandable. Not as many people in a Minecraft currently. And then finally, the other big trend was painting. Not painting a picture, but painting just your whole house. Was this like a plan already? Because I swear, like 12 people told me they were going to paint just over spring break. They said, I'm just painting my house. Did you already have it picked out? Or I don't know. Okay. It sounds like you guys had a great time, which I'm really glad. I hope you got well rested. And while maybe it wasn't what you expected it to be for spring break, that it was still restful for you. Kind of showed you some reflection time, right? People do their best work sometimes during quarantine. Isaac Newton, for example, had his miracle year when he was quarantined from smallpox from Cambridge, which was when Cambridge was a kind of a terrible college to begin with. So, life comes at you fast. All right, let's go ahead and dive into today's assignment. So first off, this is your Google form. This is your attendance. Please do this first. It should take you anywhere from 5 to 10 minutes. It's just a few quick questions about what we're learning about, just sort of reflecting. Are you understanding the material? I'm not grading it, so there's no penalty, if that makes sense. And then also just like some feedback questions, just because I miss you guys. Next to that, I'm also posting every time our PowerPoint that we are using. My voice accompanies those things. And then finally, your assignment for the day. So let's go ahead and look at our, Okay, I'm going to try to go through these notes quickly because my videos have been greatly increasing as social distancing continues. And I think that's just because I'm tired of not hearing my own voice. So I promise to make this as brief as I can. I'll only go over the parts that I think you guys might have issues with. Which includes this first part because, yay, it's great. Measuring the speed of light was a task. Oh my goodness. How were we going to measure something that occurs at 300 million meters every second? That's so fast. The first person to try this was Galileo. He basically said, hey, I've got a light, you've got a light, you're about a mile away. Press a button whenever you see my light, all right? This wasn't very successful. Number one, his assistant was only a mile away, all right? Not very fast. Light travels this many meters per second. Light was already there, all right? And they don't have the timepieces to sort of cut down on how long a second is. So the only thing this really resulted in was the ability to measure human reaction time, which, interestingly enough, is still 300 years ahead of the first reaction experiments in psychology. Yay. The second person did like we all like to do in science, and he discovered something accidentally. Romer was measuring the times when Jupiter's moons disappeared behind the planet. He noticed that these times varied over the course of a year, depending on how close Earth was to Jupiter. He was able to figure out that span of time, approximately 22 minutes, I believe, varied in how close Earth was. So he was able to calculate both that time span that you didn't see the moons and the distance from Earth to Jupiter. And he was able to sort of calculate, he didn't calculate how fast light was, but he showed that it was constant, that it was the same about each time. So that it had a finite speed. Then we have this guy, Fizeau. Super great idea. And let me get my clicker over here. Okay. He set up an experiment of which a light source bouncing onto a mirror was basically a ray that passed through a sort of wheel or gear that had sort of cutouts, let's say. So they had different notches, and he noticed that light traveled through those notches to a mirror several miles away, and then that mirror was able to reflect it back. If the wheel was timed correctly, then the mirror would reflect it back just in time for it to pass through the next notch in the wheel, and thus create sort of this unbroken ray of light. He used the speed of the mirror that was turning, and the distance away from the mirror. It was, I forget how many miles, but it was a while. Like, it was a pretty good distance, long enough to be able to judge how fast light was. And he calculated light at 3.13 times 10 to the 8th meters per second. So not our precise number that we currently use, but pretty close considering that technology. His discovery enabled us to slowly get closer and closer to the true speed of light. It's like 2.99827. Or just 3. 3 times 10 to the 8th works fine. And now our speed of light is so precise, we use it to define the meter. If you guys remember reading this article at the beginning of the year, we have now come full circle to understanding. Before, you needed to know what a meter was, and now we know what the speed of light is, and we're just using them to describe the same thing. All right, the expanding universe. Okay, so Hubble, an astronomer, he was able to create a method to determine the distance to other galaxies in the 1920s. He noticed Doppler shift. So Doppler shift doesn't just occur for sound waves, it occurs for all waves, including light. He noticed that there are blue shifts and red shifts to objects within our universe. Things that are blue shifted means that they're moving away from us. Sorry, reverse that. My bad. Blue shifted means that things are moving towards us. They're coming closer. The reason for that is because those waves are compressed. They're getting closer together. So shorter wavelengths, higher frequencies. There's more of them, right? And that describes light that is sort of blue or violet in color coming towards us. Red shifted, however, means that objects are moving away. Most objects in our universe are red shifted, so they're getting further and further away from us. But not just from us, but from everything. Objects are getting farther and farther away from things. So only a few things are blue shifted, and they're tend to be pretty local, pretty close to us, maybe within our solar system or within the confines of our galaxy. So Hubble noticed this, and this told us a few different things. Number one, that the speed of light can help you calculate how far away objects are in the universe. And number two, this sort of helps start the ideas for the Big Bang Theory. This kind of kicked it off. So the Big Bang Theory is the idea that the universe at one point was an incredibly hot, dense, like you can't even imagine how dense. You packed so much matter and just stuff into such an infinitesimally small space. And then all of a sudden, that expanded rapidly. The objects that left the Big Bang, we say objects, it's actually space-time, had a higher speed and are farther away today than things with a lower speed. If you would like a longer and more beautiful, I would say, definition spoken to you in a just lovely voice, then Neil deGrasse Tyson here has an excellent brief history of everything video. It's 5 minutes long, I think, and explains like the entire universe. So yeah, there you go. Meanwhile, it's going to take me like 20 just to tell you what you're doing tomorrow. Remember that a theory, when we talk about it in science, is not the same as a hypothesis. So when we use them in our everyday life, we're like, I have a theory that maybe like she killed her husband. That just means I sort of have like a gut reaction. I have a feeling, I have maybe a tiny bit of evidence, but not really. A theory in science has just as much backing as a law. A law is just usually with a mathematical formula. A theory is a model that explains how or why something happens. It can incorporate laws, and laws can incorporate theories, and often they work together to sort of back the same things. They usually have just as much evidence and experimentation as a law. So when we say theory, we mean this is the accepted model of what we think happened and why it happened this way. We're going to go with this answer until a bunch of other evidence turns up and overturns it, which does happen, but not as often as you would think. All right, so this is what we're sticking with. Okay. Eyes. Eyes are so cool. So moving on now to color. Okay, so if you guys are reading this now, looking at this picture, you're probably seeing a lot of different colors, right? However, there's only 3 that your eye can actually detect. Those colors are red, blue, and green. Whoa, right? So the human eye only has 2 different types of cells that detect color and light. These are rods and cones. They're located at the back of the eye. Everything else in the eye is basically just a way to protect those suckers at the back. They transmit information to your optic nerve, which then relays it to the part of your brain that interprets visual signals. You have rod cells for your vision in low light, so kind of like your night vision, or the vision that detects things from like the corner of your perception, which is actually the best way to detect movement. So if you're ever trying to pay really, really good attention, if you're ever looking for like a movement, you're actually supposed to observe from the corner of your eye if you can. Meanwhile, cone cells detect color and vision in bright light, and you only detect, again, these 3 different types of colors. Why those? Why is the world so biased against purple or orange, for example? Well, this is why. Unlike what you learned in primary school, which was mostly a lie, primary colors include red and blue, true, but also green. These are the only cones in your eye that detect color, and they are the primary colors of everything, and also the additive primary colors. This means that all 3 of those colors, down here you can see, if added together, are going to produce white light. In fact, all technology, if we look at pixels on screens, use 3 dot colors, the combination of these, and then varying the brightness of your screen, lets you see these colors, these ones only. If you look, however, so green and blue sort of overlap here, green and red overlap here, green and red light. So this is not the same thing as pigment. If you mix paint colors, this will not happen. That's pigment. It's different. All right, this is light overlapping. So if we mix green and red light, we get yellow. So the color yellow doesn't actually exist. It's just green light and red light being reflected into your eyes. If anything, all of the color in the world is just a mass hallucination by all of us at the same time. So these are our additive colors. Then we also have subtractive colors, of which there is yellow, magenta, yellow, magenta, and cyan. Never sure if I'm saying that right. If these colors are combined, they produce black. That's why we use them as ink for printing everything. So, quick note, if your printer ever runs out of ink, which you should not have a printer because printers are expensive and a waste of money, then they are going to use your color printer cartridge instead of your black printer cartridge. They can use the exact same way if you run out of one. However, I'll let you know the color ink is way more expensive. All right, a couple things about light. While the speed of light is a constant, it is only a constant in a vacuum. Things get weird as you put light in different medium. One of those things that happens is as light passes through transparent objects. So remember, light is a wave. As it passes through objects, it causes the atoms within those things to vibrate and oscillate as well. So here I have a very old, kind of dirty candle. Okay, light is passing through this glass, again, probably not very well, it's a little smoky, and that glass is absorbing those vibrations and re-emitting the light that passes through it. However, as it goes through this object, some of that light slows down. So even though light is a constant, it's only a constant in a vacuum. Otherwise, it can change both the speed and the direction depending on the object it passes through. Now, opaque materials, or anything you can't see through, absorb light but don't re-emit it. Instead, these things, the vibrations of the light are just turned into vibrations within the molecules of that thing. So maybe let's look at the candle again. Down here, this is opaque. I cannot see through the apple cinnamon part of the candle. Instead, the light passing through causes vibrations within the atoms of this candle, and those are turned into random kinetic energy, which, if we remember, kinetic energy of molecules is just heat. So it's just giving off heat. It's just soaking it up like a cat. That's what cats do. There you go. All right, a couple other things about light. Reflection is as waves reach a boundary between two medium, some or all of the waves bounce back. Refraction, as a beam of light passes from one material into another, it changes two things, both the speed and the direction. So lots of different materials have a known index of refraction. This is the speed of light through those materials. This is an index that tells you how light is affected through those materials. So glass has one, air has one, water has one. These are all transparent materials, or can be, of which light passes through, but the speed and direction of light is affected by those things. Okay, this is a common analogy. You can read it here. Polarization, and also what today's lesson is about, is so polarization refers to one thing in particular, and that's the direction of light as an electromagnetic wave. So if you remember, light is an electromagnetic wave, and those waves pass in different directions to each other. So you might have the electric part like this, and the magnetic part like this. So parallel, perpendicular. Polarization refers to the direction of the electric field in a light wave. It points in the same direction as the electric field. Now, cool thing. Polarization doesn't necessarily matter that much to us, but it does matter to lots of other animals. So bees use these to navigate across flowers. Actually, if you ever looked up bee vision, it's really, really weird. Bees are weird. I mean, important, but weird. And then also some birds use the polarization of light when migrating. So if you've heard that different animals can migrate using magnetic fields, this is part of the reason why. If things are linearly polarized, then that means that electric field is pointing in the vertical direction. Meanwhile, unpolarized means that light's polarized in random directions. You can have a polarizing filter, like on sunglasses, for example, which does two things. It blocks out light intensity because it blocks about half of the light passing through. And then so if you'll notice here on these polarized frames, this is a little bit darker in background than over here. Sometimes people think the color looks more saturated. And then also it changes the direction to that as the same axis. So if we look here, this picket fence analogy, sort of imagine light going through this way when both fences are aligned in the vertical direction, then vertical vibration goes through both things. So here's supposed to be like a wave or a jump rope going through this picket fence. Meanwhile, if they were aligned in opposite directions, so this is vertical and this is horizontal, then it goes through this one, but see, it's blocked. It can't travel that way. So polarizing sort of resets that axis. There's a couple different applications. So polarized light is shined onto different models, sometimes of plastic building models for design projects, sometimes for dentistry, for like teeth, and then also for prosthetic joints. And this sort of allows us to see where the stress is going to be put on that object. All right, last but not least, there are lots of different ways to polarize things. One that occurs naturally is called scattering. This is when sound or light is absorbed and it's re-emitted in all directions. So it's just like what it sounds. It's passing through, but instead it's absorbed and then re-emitted in all directions. Light is scattered by particles in our atmosphere. The smaller the particles, the higher the frequency of light it will scatter. This is the reason for a lot of things, which you're going to learn about in this assignment. All right, and here is sort of hard to get a good picture for polarized versus unpolarized, but I thought this would help. It's polarized light, light's vibrating in any direction, passes through that filter, and all of a sudden it's aligned just straight upwards, right? For unpolarized light, it is still going in multiple directions. Why would they? Okay. And that is it for today. Oh, oops, started a new thing. Okay, let's go ahead and look at what your assignment is. All right, so it's a small, very small research assignment. Yay for research. First thing, guys, in this assignment, I would like you to cite your sources. Because I'm incredibly biased on types of source citing, I would prefer you to use the APA as standardized by the Purdue University. Not that they standardize it per se, they just have like the best website. It doesn't matter. Okay, so on this assignment, you're going to have to research some things. Use your best judgment on websites. I trust you. If you go to Wikipedia is awesome and I love them, but you should scroll to the bottom and look at the references that Wikipedia got and then go to those places. That's how that works. All right. Make sure, if it's sometimes hard to find online sources that have the author's name, if you can, then go ahead and include the last name of the author and then their first and middle initial is what's common. You probably won't find their middle initial. That's more common for journal articles. And then either the date that it was published. Again, most online sources just list the year, usually at the bottom. Go ahead and search for that. the title of the page, so the title of the article, if there is an article that you use. The site name that you got it from is not the same as the URL, okay? And then finally list the URL, or if you just want to hyperlink it to the site name, that works too. And for this assignment, I would like you to answer these 3 questions. So polarization has lots of applications. I included 3 things that polarization is used for. How do sunglasses work? How do 3D movies project? And how do our mirrors and reflective surfaces created? Choose one, answer in complete sentences, cite the sources that you get, please. How stuff works is a great reference for this. Maybe start there. If you have other ones that you would like to add, like for example, if you just know a bunch of weird things about polarization and you would like to talk about it because you know about it already, then just email me and ask, all right? And finally, questions about color. These are mostly related to scattering, polarization that happens naturally. Why is the sky blue? Why are clouds white? Why does the water appear this way? Wow, your family with all of your scientific knowledge. You can be the actually person that just pops up. And then also here's a fun little saying, assess it for any validity. For these, I would like you to choose 2 questions to answer in complete sentences. If your answers are because it just is, that's a terrible answer. You should just try again, okay? These have to relate back to both polarization, scattering, the wavelengths of light, and just double check the rubric, all right? And with that, let me know if you guys have any questions. Sorry, I said this was going to be brief. It was a lie.